Today we are going to see about project hybrid approach using vector quantization and K-Knn for classifying speech signals. This project is done by my friend Inbadamlan Balasubramanian and me Prasit Reddy Chauva. Now we are going to look at the introduction of the project. In this project we use Q-Knn. Q-Knn is nothing but quantized features are used by the K-Knn model. Then we will see about what is quantization. Quantization is nothing but it is used to reduce the dimensionality of the features and compress the data without losing important information. These quantized features are sent to the K-Knn model to fit the ML model to classify labels. Then why are we going with Q-Knn approach? Because as the data set has 26 million, we cannot straightly use this data for the K-Knn model as it is computationally expensive. No problem taken. Speech classification tasks such as recognizing different phonemes, words or categories require efficient and accurate feature representation. In this project, we specifically aim to reduce the dimensionality of the MFCC features, improve classification accuracy using hybrid approach, and implement an efficient and scalable method for real-time applications. Now we look at the workflow for the vector quantization. In the collected data, there are five class labels: AMFCC, BMFCC to till EMFCC, where each class has train data and test data separately. We combine all the train data and test data and separate X train and Y train, where X train is the all the features of the class and Y train is the class label. After separating, we scale the X train and assign codebooks. Codebooks is nothing but the cluster. After assigning the cluster, we do vector quantization by using k-means and save the quantized features for a future K-Knn model. Now data points. As mentioned earlier, there are five class labels AMFCC till EMFCC, which has train data and test data separately. In this train data and test data, there are multiple CSV file where they are combined using combined train data and combined test data. This test data is again separated as test data and validation data. The combined train data has the shape of 26 million and 27 features, where the first 26 columns are the features of the class and the 27th is the class label. Now after combining the train data and test data, we go with vector quantization hard decision. Here hard decision is nothing but the k-means model. The combined train data is sent to the k-means model, where it is used to fit the model and store the k-means model and the encoded features. This is the code for the vector quantization in k-means, which is done in our lab. Now after calculating the quantized vectors, we assign the centroid class using distance based approach, where for cluster 0 it is DMFCC, for cluster 10 it is BMFCC, like that. For all the specified clusters, the class is mentioned by using distance based decision. Now evaluating k-means. This is the code for evaluating the k-means model. For fitting the model using that trained model, the predicted test classes are evaluated and the test accuracy is about 30.16, and this is the code for testing the evaluated that trained k-means model. This is the confusion matrix for the evaluated k-means model, where the diagonal elements are the correctly predicted class labels, and this is the classification report, and the overall test accuracy is about 30%. Now k-nearest neighbors. The quantized features in the training data and the test data, using the quantized features in training data, K-Knn classifier is trained, and the test data is used for predicting the saved model, and this is the code for predicting the K-Knn model we saved using the test data. Then the test accuracy we got is 49.18%, and this is the confusion matrix for the K-Knn model, where the diagonal elements are the correctly predicted class labels, and this is the classification report for the model, and the overall accuracy is 49%. Now we also tried with the soft decision. When comparing with k-means model, GMM takes longer computational time as it uses EM algorithm with GMM. And thank you.